Hey everyone, and welcome to today's Explainer. We're about to take an incredible virtual journey to see exactly how plants manage to survive in the absolute wettest and the absolute driest places on Earth. It's a fascinating story of nature's survival skills, and it's all driven by one single ecological factor: humidity.
But before we really get going, I want you to think about this for a second. How does a cactus survive for months, literally baking in the hot desert sun without a single drop of rain? Like, how is that extreme desert survival even scientifically possible? Keep that in the back of your mind, because by the end of this, you're going to know exactly how they pull it off.
All right, let's start with the basics. What exactly is humidity?
Well, humidity is simply the amount of water, or water vapor, floating around in the air and the soil. And moisture in nature varies wildly. In deserts, water is incredibly scarce. But if you travel to a tropical forest, humidity is super high. Or if you're standing near a river or a swamp, the air is just way more humid than if you were out in a dry, grassy steppe.
So why does this matter so much? Well, plants need water for some absolutely crucial, life-saving jobs. First up is photosynthesis. That's how plants use sunlight and water to make their own food. Then there's the transport of nutrients. Think of water like a busy highway that carries food from the soil straight up into the leaves. It's also super important for maintaining cell structure, keeping the plant standing up tall instead of just wilting over. Plus, it cools the plant down, kind of like how we sweat on a hot day, and it's needed for overall growth and reproduction. But it's a really delicate balance. Too little water and the plant dries out, but too much, the roots can actually rot because they can't get enough oxygen in that soggy soil.
Moving right along to our first group, water-loving plants, or if we want to use the scientific term, hydrophilous plants. Check out how these plants are perfectly adapted to their soggy homes. Since they have so much water, they actually need to figure out how to get rid of the excess. So they develop these really large, thin leaves to help evaporate that extra water super quickly. And since water is literally everywhere around them, they actually have pretty weak root systems. I mean, long roots just aren't needed when you don't have to go searching for a drink, right? They even have special air spaces in their tissues so they can still get oxygen even when they're stuck in completely waterlogged soil.
Let's look at some real-world examples. We've got the beautiful water lily, the tall reed, and rice, which actually grows right in flooded fields. There's also moss, the fern, and the classic swamp cattail. Every single one of these is a hydrophilous plant.
Okay, here's an awesome fun fact for you. Have you ever wondered how water lily leaves manage to just sit so perfectly on top of a pond? Well, those large leaves float entirely thanks to those built-in air spaces we just talked about. They act like tiny little life jackets, keeping the leaf buoyant while also helping the plant breathe. How cool is that?
And here's another amazing fact: mosses can absorb a massive amount of water, literally just like a sponge. Since they don't have deep roots to pull water up from underground, they just soak up whatever hits them. It's a perfect adaptation to a totally soaked environment.
Next up, let's talk about plants of moderate climates. These are called mesophytes.
These plants live in sort of a Goldilocks zone. Not too wet, not too dry. Because their conditions are so moderate, they really don't need any wild survival tools. They just feature a nice, well-developed root system to reliably pull water from the soil, and their leaves are usually medium-sized. They don't have any crazy adaptations for extreme drought or crazy floods because, well, they simply don't need them. These are probably the plants you see every single day. Things like the mighty oak, fields of wheat, and the classic apple tree. Birch and maple trees are great examples too. They absolutely thrive in these wonderfully balanced, moderately moist climates.
All right, now for the toughest ones: drought-resistant plants, known as xerophytes.
In the absolute harshest, driest climates on the planet, water is incredibly precious. So the #1 priority for these plants is stopping water from evaporating. They do this by having very, very small leaves, or sometimes turning their leaves into sharp spines. They also develop thick, fleshy stems to store whatever water they can manage to find. Oh, and they often have this thick, waxy coating on their leaves. It acts just like a seal to lock the moisture in.
Now think back to those weak, shallow roots of the water-loving plants we saw earlier. It is completely the opposite for xerophytes. They have incredibly long root systems because they have to reach deep, deep down into the dry soil just to find hidden underground water. It's a completely different survival strategy.
Take a look at these tough desert survivors. You can really see their unique shapes. There's the classic cactus covered in spines, the rugged saxaul and wormwood, dry feathergrass, and the spiky agave. Literally every inch of their structure is specifically designed to hold on to moisture.
And, hey, this brings us right back to our starting question. How exactly does a cactus survive for months without rain? Well, the answer is that they act as living, breathing water storage tanks. They have these thick, fleshy stems designed specifically to hold water for months at a time. It lets them take very slow, steady drinks during those long, brutal desert droughts.
But, it's not just about their physical shape, it's also about how they behave. Here's a really cool one. Feathergrass actually rolls its leaves up when the weather gets hot. By rolling up tight, it hides its surface from the scorching sun. It's just a brilliant behavioral adaptation to reduce water loss out there in the dry steppes.
All right, let's wrap up this biome tour with a quick summary.
Bringing it all together, we can really see nature's complete biological toolkit. Depending entirely on the amount of water available, plants have developed totally different tools. You've got spines, long roots, and thick stems for the dry deserts. Then you have massive leaves and built-in air spaces for the wet swamps. Thanks to these specific tools, plants can successfully live in pretty much any environment on Earth.
And that brings us to the biggest takeaway from today's explainer. Plants survive because of amazing adaptations to water conditions. But it definitely leaves us with a big question to think about. As our global climate shifts and these environments start to change, will these ancient survival tools be enough, or will plants have to figure out how to adapt all over again?